Hey everyone, this is Will from Master Amplification, and today I want to do a little video on isolation transformers. Specifically, I wanted to talk about the isolation of the ground on an isolation transformer. I go to a lot of forums and watch a lot of YouTube videos and go to a lot of discussion boards and stuff like that, and I get a lot of people that are talking about isolation transformers and why one needs one when they're doing electrical work with electronics repair on the bench and all those types of things. And I think one of the things that's overlooked is the fact that the ground needs to be isolated as well. So it's not just an isolation transformer. So we're going to take a look at some things. I'm going to kind of briefly go over what an auto transformer is, what an isolation transformer is. Those are the two broad categories of transformers. And I'll put some links down below to some places where you can go for better understanding of why you would need an isolation transformer in general. I know X-Ray Tony B has a really good video. Blue Glow has a good video. There's a couple others. I'll put some links down below. And but I just wanted to hit on the piece about, I think the most overlooked piece is the isolation of the ground. And I was going to do this on the bench with some examples that I have out there on the bench. But I was going to be going back and forth between schematics and live examples. So I just decided to do it this way. We're going to do it right here on the desktop with a screen capture. And I can kind of go through it with you and kind of show you what I'm talking about. So let's get with it. So this is an example of a variac or an auto transformer. Variac is actually a registered trademark name. It was originally trademarked by the General Radio company, or the General Radio Institute, I believe it was called. But now I believe that name actually is owned by another company called ISE. Forget what that stands for. But it basically is still being used. But what it was short for was a variable AC, and typically you'll see other versions of this. Here's another variac that's a little bit older. We actually use these on my workbench at work. And then typically you see these being sold, online, these cheap Chinese types. They'll either have these kind of screw terminals on them, or they'll have regular NEMA 5 outlets on them as well. So, but these are basically auto transformers, and I'll pull up the schematic on that to show you what that looks like. So right here you can see an auto transformer doesn't isolate you from the load. It's basically just the line, and you've got different tap-off points that you can pull off on that line. It's just a single winding. It's basically a primary winding is what it amounts to. And you can just tap off different spots of that winding and feed your load with different voltages. And you can get from 0 up to line voltage on this particular type. They also make some other types where they wrap this around and you can get even higher than line voltage, but you're still not isolated from the line voltage at all, or the line here on this side. You're not, it's got a physical connection here. So what we're going to be talking about today is isolation transformers. So let me pull that up. So what many people think about when many people think about isolation transformer, they think about usually they think about a 1-to-1 ratio transformer that you use to isolate a piece of equipment from the line. That's basically what people kind of have in their mind when they think about an isolation transformer. But really and truly, an isolation transformer can be any ratio. In fact, your power transformer on your pole that is feeding your house is an isolation transformer. Pretty much every transformer that's not an auto transformer, like we just talked about, is an isolation transformer. That is that it's physically separated from the line. There's a primary winding, there's a secondary winding, and there's a galvanic isolation there where basically the voltage is transferred from one winding to another via some induction. There's a lot more to it than that. I won't go into that, but typically we think about a little transformer that looks kind of like this. And almost every transformer, and we use these at work where I teach in the lab, and almost everyone that I've ever seen, the ground plug here, or the ground terminal on the line side, and the ground spot on the outlet on the secondary are almost always have continuity between them. In other words, somewhere internally in here they're connected, and so that is not helping you at all. Uh, as far as the ground goes, it doesn't help you. Now you still have the isolation from the line part, but if you've seen other videos where they talk about needing an isolation transformer to separate, your O-scope from a piece of equipment that you're testing, because your O-scope outer connection on the BNC, the little clip for your reference, is at ground potential, is connected to ground actually. So it's connected to the ground lug on your actual power line. So that's when you need that actual separation, because you may have a voltage that's on a piece of equipment that you don't want to be taken to ground, and that would do it. So you could have a floating chassis type of ground that's not at regular ground potential, or you can just have different voltages, different places that you don't want on the ground. So there's a lot of different reasons why you would want to have this ground isolation, but almost all isolation transformers that I've ever found do not have ground isolation. So the easy thing is that the ones we have at work, we just pull this little plug off right here, so we don't have that going back to the ground. Or you can lop this end off and fashion another outlet onto this secondary side as well, however you want to do it. You also have isolation transformers that look like this. We use these at work. This is a Tenma 72 1095, and this is a variable isolation transformer. And so you kind of get the best of both worlds with this, because not only do you get the variable voltage out of it like you did with an auto transformer, but you also get the isolation that you get through the galvanic isolation of this. And these can be set up different ways. You can either have like an auto transformer going into an isolation transformer, or vice versa. I'll show you a schematic of that here in a minute. But what I found on these is the ground is connected on the inside here to a lug on the chassis. The ground on this outlet right here, and on the receptacle. And then on the power line coming in, the ground is connected to the chassis itself, and you can actually have continuity between this and that other ground prong on the power line cord. So it's pretty easy to isolate that ground. Just go in here and take the case off of this chassis here, and there's a little lug down there. You can just unscrew it, take the ground off, tape it up, whatever, and then you'll have an isolated ground off of these things. And these things are great. I use one pretty much every day, and I really enjoy these, because you get the best of both worlds as far as having a variac or auto transformer and an isolation transformer all in one. And you can monitor current and voltage. So you have to click one off and to click one on. They both use the same meter. I actually modified one with a digital display on it to get both, and power and power factor and whatever else is on there. But this is a very good isolation transformer to use. But you have to realize that the ground from the factory, this thing doesn't come isolated with the ground. So let's look at a couple of schematics here, just a moment. So right here we see that this is a variable isolation transformer, and you can see it's got a 1-to-1 ratio isolation transformer here, and then it goes into like a variac, right? And then you can get your whatever 240 to 12 volts or whatever on this winding right here, right? And so it's still an isolation transformer. It's just combining an isolation transformer and an auto transformer. On this one, we're actually putting the variable part up front with the auto transformer and then running it through a 1-to-1 uh, isolation transformer here. So you can see it's set to 12 volts. So I've got 12 volts on the output here. Wherever this is set, this is going to be a 1-to-1. So that's the two ways that it can be done. I'm sure there's several other ways with maybe some kind of nonlinear type of power supplies and stuff like that. But in the linear world with linear transformers, this is pretty much how they do it. And they typically use a toroidal transformer for these because they can make these units a lot smaller than if this was a normal, regular transformer. So that's kind of what that looks like. Now, I saw a lot of people on these forums talk about medical, and I don't want to get into this too deeply, but I just want to bring it to your attention that I've heard a lot of people on these forums and other places talk about, well, you need to get a medical grade isolation transformer, and that will solve your problem. And so I did some research. I always heard about these medical grade isolation transformers. And from what I've seen, the medical grade isolation transformer is not necessarily got separation of the grounds. In order to be considered a medical grade isolation transformer, it's got to meet certain RFI, EMF, radio interference and noise filtration requirements, shielding requirements, reliability requirements. There's a whole bunch of different ANSI and IEEE type of standards that it has to meet in order to be considered a medical grade isolation transformer. It's got to have, thermal protection and all kinds of things. But an isolated ground is not one of them. So I'm sure there are probably some out there that do have isolated grounds, because I do know that ground loop current issues are a problem in hospital that's running a lot of different equipment and stuff like that. So there are probably some equipment out there that does that, but I would not automatically buy a medical grade isolation transformer with the hopes that it was going to be isolated. I would definitely check it out. So that's that. So that's pretty much where I wanted to kind of make sure that gets out there, because all too often times it's kind of overlooked, the whole ground isolation thing. So just make sure that if you're using an isolation transformer for a reason that you think that you're being separated from ground with it, you may not be. As a matter of fact, I'm going to say 90% of the times, unless somebody's went in there and actually disconnected it, you probably aren't isolated from ground. The ground is probably continuous throughout that isolation transformer. So just be aware of that. And you can just make modifications to the piece of equipment. But then at the same time, you also need to know that if you do need that ground for whatever reason in a different application, because you're going to use it in a different application besides testing something on a bench, then you need to make sure that you know that that thing has been disconnected and you need to actually put it back. What a lot of people also say is, well, why don't you just run all of your O-scopes and equipments and stuff like that through an isolation transformer? And that's really not the way to go with it, because you kind of want the equipment to have a good ground reference. And then too, if you've got a lot of equipment that have, that need that ground, that's all going to be on the same ground plane, you don't want, everything plugged into isolation transformers. So it's just better to put your specimen under test, or your unit under test, or whatever you're working on an isolation transformer, and keep all of your other equipment properly grounded and everything to the line ground. So that's the way I would do it. That's the way I think most people say they do it, and I think that's the standard. So if you got any questions, go ahead and put it down in the comments below. Any comments, I appreciate all the feedback. Anything you have to put down there. Like I said, I'll have some links down in the comment section below about some videos that other people have done specifically about isolation transformers and why they use them in the situations they do. I just wanted to put out this little clip to kind of clarify some things or to make sure that something wasn't overlooked. Thank you for watching.